Okay, so there are some fancy schmancy definitions of increasing and decreasing. You do not need to memorize these definitions, but what I do need you to know is that the definitions all have this x1 is less than x2. And if you think about like an interval x is less than 3, you would use parentheses, right? When you have a strictly less than, you would use parentheses. So because of this definition where I have x1 is less than x2, and that's in every part of increasing, decreasing, or constant, the way it's defined, we are going to need parentheses. And every time you are reporting your answer on the homework for where is it increasing and decreasing, you are going to use parentheses to report increasing and decreasing. Your answer is never, ever going to have a square bracket. And the reason why it's never ever going to have a square bracket goes back to this definition that x sub 1 has to be less than x sub 2. So the first thing that I need us to remember from college algebra is that if I am looking at where it's increasing and where it's decreasing, I always use parentheses. That is every single time. I'm never going to use a square bracket, and it comes from that definition. Now, the second thing that I need us to remember, or we want to remember from college algebra, is what do we mean by increasing, decreasing? So the key thing to remember is that when you read a book, you always start on the left-hand side and you go to the right-hand side. So the same thing is true when we read a graph. When we read a graph, we are going to go from the left-hand side to the right-hand side. So back in college algebra, what they would do is they would say, okay, going from left to right, if I were a little man going up this hill, the little man would be going up the hill, right, from left to right. So we said if it's going uphill, then it's an increasing function. And the same thing was true if it was going downhill from left to right, then we said it was a decreasing function. So again, if our little man was going down the hill, then it was decreasing. And then if there was no hill, we said that that was a constant function. So if our little guy was just walking on a flat surface, then it's constant. But again, we're reading it just like we read a book from left to right. All right, now here's our goal. Our goal is to not have a graph, and our goal is to connect this increasing concept to the derivative. Now, I don't want you to write this down. I just want you to watch this, okay? So here's the situation that we have. So we have our little graph. So here's my little graph, right? Okay, now if I draw a tangent line here, I draw a tangent line here, draw a tangent line here, draw a tangent line here, you will notice when you look at those tangent lines that they all have positive slope. And remember that the slope of our tangent is the derivative. So when we look at these increasing functions and we see that all the increasing functions, every tangent line I could possibly draw has a positive slope, that tells us that our derivative is greater than 0. Because remember, the tangent line slope is the derivative. So what we're seeing for increasing functions is that the derivative is positive. It's always strictly greater than 0. Now, that is not the case with decreasing functions. When I look at decreasing functions, again, here is my graph. And if I take and I draw my tangent here, my tangent here, my tangent here, and my tangent here, all of those little tangent lines have negative slope. And what we're going to see is that is true. Any decreasing function that you draw, you're going to see that when you draw the little tangent lines, they all have negative slope. So if it's decreasing, the derivative is negative. And then our final thing that we can kind of surmise from this picture is that if it's a constant function and we draw these tangent lines, you'll notice that those tangent lines are all horizontal. So when it's constant, the derivative is equal to 0. So to try to figure out where the function is increasing or decreasing without drawing a graph, what it really boils down to is figuring out where is the derivative greater than 0 and where is the derivative less than 0. And so that's going to be our goal in the next section or in the next page is we're going to be trying to figure out where is our derivative positive and where is our derivative negative. All right, so again, to find the intervals of increasing, we need to solve the inequality f prime greater than 0, f prime less than 0. All right, so most of this page is just kind of an introduction. The two takeaways that I need you to have, first of all, if you're working with increasing or decreasing, you're always using parentheses. And then the second one is increasing is looking like a derivative greater than 0, and decreasing is looking like a derivative less than 0. So if we want to find those intervals, we are going to need to solve an inequality. We're going to need to solve f prime greater than or f prime less than.